This video will be focusing both on the proper use of the scientific calculator as well as significant digits when completing chemistry equations. The 4 problems you will see in this video are actually the same 4 problems that you will see in the following videos. Despite the fact they are the same problems, the videos will focus on different aspects. This video will focus on the use of the scientific calculator and the specific steps that need to be taken within the calculations. It will also focus on significant digits through explanation of the rules behind them, as well as the demonstration of how to determine and apply them. We will first discuss calculator use. A few important things to remember when using the scientific calculator to complete chemistry equations include: division or multiplication by 1 does not change the final answer. Therefore, it is not necessary. Meaning, if you come across a unit of 1 pound, you can skip it and divide or multiply by the next number that is not 1. Also, if you are multiplying or dividing by a power of 10 that does not have a number in front of it, you must first put the number 1 before hitting the second key followed by the E key and then type in the power. I will demonstrate what I mean by this. So you have your calculator, and let's say you are asked to multiply by 10 to the 7th. Since it does not have a number in front of it, we first need to type the number 1, followed by the second key, followed by the E key, and then we will type in our power. In this case, it was 7. In doing so, it will give you the correct calculation. Also, once you have multiplied everything on the top of the equation and begin to divide, you must hit the division key in between each new part of division. Meaning, if you multiply the numbers 1, 3, and 7 together, then wanted to divide them by the numbers 2, 9, and 10, you must type in 1 times 3 times 7 and then hit the equal button. Next, you need to do divided by 2 equals divided by 9 equals, and lastly, divided by 10. I'll demonstrate what I mean by that. So first we are taking 1, hit the multiplication key, times 3, multiplication key, times 7. Then we are hitting equals. Then we are hitting the division key and hitting 2 equals, division key, hitting 9, selecting enter, division key, and then finally selecting 10, and then selecting enter. In doing that, we are given the correct calculation. Also, the expression multiply everything on the top and divide it by everything on the bottom simply means that all of the numerators get multiplied together and are then divided by each individual denominator. We will now discuss significant digits. At first, significant digits can seem challenging, but with practice it will come naturally. The common rules for the application of significant digits include non-zero integers, which non-zero integers always count as significant digits. An example of a non-zero integer would be -2, 3, or 5. Next, we have leading zeros. Leading zeros are zeros that precede all non-zero digits and are not significant digits. An example of the leading zero is in the number 0.00037. These 3 zeros after the significant digit as well as this one are what we consider leading zeros and do not consider significant digits. Therefore, this number only has 2 significant digits, being 3 and 7. Next, we have captive zeros. Captive zeros are the zeros between non-digits, apologize for that, and they are always considered significant. My example of this is the number 1.304. The 0 in between the 3 and the 4 is what we classify as a captive 0. As stated before, they are always considered significant. Therefore, this number has 4 significant digits. Next, we have trailing zeros. Trailing zeros are the zeros at the right end of the number, and are only significant if the number has a decimal in it. I have 2 examples for this. The first example is the number 200. The 2 zeros following the number 2 are what we classify as trailing zeros, and are considered non-significant. Therefore, the number 200 only has 1 significant digit. In the second example, we have 2 zeros following the 2 again, only in this case we have a decimal point in between the 2 numbers. The decimal point thus makes these 2 zeros significant. Therefore, the number 2.00 has 3 significant digits. Lastly, we have exact numbers. Exact numbers are assumed to have an infinite number of significant digits and do not play a role in determining the number of significant digits. The example I have here is a problem that asks how many centimeters are in 3.65 feet. As you can see here, I have already done the unit conversion, and the example of an exact number in the unit conversion is 2.540 centimeters. As previously stated, this is the exact number, and it does not determine the number of significant digits in the final answer. What determines the number of significant digits is the number in our given, which is 3.65. The number 3.65 has 3 significant digits, therefore our answer is given in 3 significant digits, and we come up with 1.11 times 10 to the second centimeters for our final answer. The concept of significant digits also corresponds to multiplication, division, subtraction, and addition. In regards to multiplying and dividing, the smallest number of significant digits present in all the numbers determines the number of significant digits in the final answer, unless the problem has given. In that case, the given determines the number of significant digits. The example I have here is 3.5 times 10 to the 7th multiplied by 3.66 times 10 to the 1st. The first thing you need to do is to compare these two numbers. In this one, we have 3 significant digits, and in this one, we have 2 significant digits. As previously stated, the smallest number of significant digits present in all the numbers determines the number of significant digits in the final answer. Therefore, 2 is the smallest number, meaning that we will have 2 significant digits in the final answer. We come up with the answer of 1.3 times 10 to the 9th. In the regards to subtracting and adding, the smallest number of digits after the decimal determines the number of significant digits. Note, the numbers before the decimal do not play a role in determining the number of significant digits. So for the example I have here, we have 503.11 plus 6.3985 plus 034. This number right here has 3 significant digits after the decimal. This has 4 significant digits after the decimal, and this has 2 significant digits after the decimal. As previously stated, the smallest number of digits after the decimal determines the number of significant digits. Therefore, this number determines it, and we will have 2 significant digits after the decimal point in our final answer, giving us the final answer of 509.54. When completing these problems, the answers will almost always have more numbers than the number of significant digits in the given. Therefore, you will need to round. For example, take the number 5.39972. Rounded to 2 significant digits, it is 5.4. you count 1, 2, and then the final, or the number to the right of the final significant digit is greater than 5, therefore we will round up, giving us the final answer of 5.4. Rounded to 3 significant digits, it is 5.40. You count 1, 2, 3. The number to the right of the final significant digit is greater than 5, therefore we will round up. In this case, this also affects the second number. So our final answer is 5.40. Rounded to 5 significant digits, the number is 5.3997. You count 1, 2, 3, 4, 5. The number to the right of the last significant digit is less than 5, therefore we do not round up, and we leave the final answer, or the final number, as is, giving us the final answer of 5.3997. Both proper utilization of the scientific calculator and significant digits are important because chemistry is exact. Whether completing a lab, homework, or a problem on a test, the answer needs to be accurate. Even one incorrect power, or being off one number on a significant digit, will lead to an incorrect answer. This is also why it is important to complete the calculations in a sequence rather than breaking the equation into separate parts. This is important because eventually rounding will occur, resulting in a less accurate answer. You can look at the example I provided for this. The directions state to round to 3 significant digits. The first and the second examples are actually the same thing, but the first one is going to be done incorrectly and the second one will be done correctly. In the first one, we are going to take 3.01, multiply it by 8.22, and divide it by 34. We will then hit the equal sign and round it. This rounding right here is the part that makes this incorrect. Once we have rounded, we are going to multiply it by 3.66 and then divide it by 3. In doing so, we get the answer of 0.8906. The directions said to round to 3 significant digits. The number to the right of the final significant digit is greater than 5, therefore we will round up, giving us the final answer of 0.891. We are going to compare that answer to this one, completing it in a sequence rather than breaking it into parts. We're going to take the number 3.01, multiply it by 8.22, multiply it by 3.66, and then divide it by 34 times 3. In doing so, we are given the answer 0.8878. The directions ask to round to 3 significant digits. The number to the right of the final significant digit is greater than 5, therefore we are going to round up, giving us the final answer of 0.888. Since we have this answer, 0.888, this one is more exact because we completed it in a sequence. The first one was not completed in a sequence, therefore incorrect. Comparatively speaking, the numbers are very similar, but as previously stated, chemistry is exact, so the more accurate, the better. And speaking of accuracy, in order to get an accurate answer, you also have to be able to properly utilize the scientific calculator. I am going to demonstrate exactly how you are supposed to type this in. We are going to take 3.01, hit the multiplication key, take 8.22, hit the multiplication key, and take 3.66. We will then hit equals. Next, we are going to hit the division key. Then we are going to have an open parenthesis and then put 34 times 3 and close parenthesis. The reason that we are enclosing the number in parentheses is because we are dividing by the answer of 34 multiplied by 3. We are not individually dividing by 34 and then dividing by 3. Once you hit the enter key, you are given the exact same answer as I came up with right here. Now that we have discussed the basics of proper calculator use and significant digits, we will now look at 4 problems that demonstrate what I have discussed. I'm going to put this here. Let's take a look at the first problem. It has already been set up, so all we need to do is multiply everything on the top and divide it by everything on the bottom. So, we are going to take 3.000 and multiply that by 5280. We're going to multiply that by 12 and then multiply that by 2.540 and then hit enter. As you may have noticed, on the bottom we have 1 mile, 1 foot, and 1 inch. As previously stated, it is unnecessary to divide or multiply by 1 because it will not affect the final answer. Therefore, we have our final answer. The exact number is 5.828032 times 10 to the 5th. We have to compare the exact answer to our given in order to determine the number of significant digits. Our given has 4 significant digits, therefore our final answer must have 4 as well. So we count 1, 2, 3, 4. The number to the right of the final significant digit is less than 5, therefore we leave it as is, giving us the final answer of 4.828 times 10 to the 5th centimeters. Now let's take a look at the second problem. As with the first problem, it has already been set up, so all we need to do is multiply everything on the top and divide it by everything on the bottom. So we are going to take 3.678 times 10 to the negative third. We're going to skip over 1 quart as well as 1 liter, and the next thing to do is multiply by 10 to the 6th. As previously stated, if there is no number in front of the power of 10, you must first type 1 and then type second key followed by the E key followed by the power. We will then hit equals. We are going to skip over 1, so next we are going to hit division key. Getting blurry for just a moment. And then we are going to divide by 2. Alright, apologize for that, it was getting blurry. Then we are going to divide by 2 and then hit the enter key. Next we are going to divide by 1.057 and again hit enter. Once we have done so, we are given the exact number of 1.739829707 times 10 to the third. We need to compare this exact number to our given. Our given has 4 significant digits, therefore our final answer must have 4. We count 1, 2, 3, 4. The number to the right of the final significant digit is greater than 5, therefore we are going to round. This also will affect the third number. Therefore our final answer is 1.740 times 10 to the third microliters. We're now going to take a look at the third problem. Take one moment for the camera to focus. Let's take a look at the third problem. As with the first 2 problems, it has already been set up. So all we need to do is multiply everything on the top and divide it by everything on the bottom. As you may have noticed, this problem is slightly different than the first two. This is because the answer is asked for in unit per unit, making the problem a little more challenging by having us complete two parts to get the final answer. I personally always put a slash to signify everything following the slash is a part of the second part of the equation. This right here is the slash that I am referring to. It is not intended to be confused as symbolic for division. You still multiply everything on the top and divide by everything on the bottom, meaning all the numerators get multiplied together and are then divided by each individual denominator. I will demonstrate exactly how to type this into the calculator. So we take 6.53 times 10 to the negative third. We are going to skip over 1 gram as well as 1 pound. Next, we are going to hit the multiplication key and enter 16. We are going to move down here and we are going to multiply by the power of 6. Again, we must first put 1 and then type in our power. We're going to skip over 1 liter. Next, we will hit the multiplication key and type in 4. Then hit enter. We can now move on to the division portion. We are next dividing by the power of 3. Again, we have to type in 1 and then the power. Hit enter. Division key. 453.6. Enter. Division key. We're going to skip over 1 pound and 1 liter. Then we are going to type in 1.057. And since the next one is gallon, we will hit enter, and that will give us our final answer. We are given the exact number of 8.716559962. We need to compare this exact answer to our given. Our given has 3 significant digits, therefore we count 1, 2, 3. The number to the right of the final significant digit is greater than 5, therefore we round up, giving us the final answer of 8.72 times 10 to the negative first ounces per gallon. We will now take a look at the fourth problem. As you may have noticed, this problem is slightly different than the first three. The problem asks, what is the molarity of a solution when 2.367 times 10 to the negative second ounces of NaOH is dissolved to make 6.543 times 10 to the negative second quarts of solution? In this problem, we need to complete 2 separate unit conversions as well as solving for the molarity. As stated before, it is important to complete the calculations in a sequence rather than breaking them into parts. Since we need to calculate this equation in a sequence, it needs to be plugged in to the calculator correctly. So I'm going to demonstrate this for you. First, we are going to type 2.367 times 10 to the negative second, skip over 1 pound. Next, multiply it by 453.6, and then we are going to hit the enter key. We are then going to divide it by 16, hit enter, and then again divide it by 40.00. As you may have noticed, that only covers one portion of the equation. The reason I typed in that portion was because this entire portion is the calculation into moles. And as we know, moles divided by liters will give us the molarity. So since we have moles, I will now hit the division key. I am also going to put this in a set of parentheses. So we type 6.543 times 10 to the negative second, hit the division key, and type 1.057, and then enclose it within parentheses again. The reason we did this as a second part for division is that this entire second part of the equation was the conversion into liters. And as previously stated, moles divided by liters will give us the molarity. We hit enter, and we are given, after rounding to the correct amount of significant digits, we are given the answer 2.710 times 10 to the negative first, and then this bolded M represents molarity. Well, that concludes all of my problems as well as my discussion. Thank you for watching my video. I hope it helped you gain a better understanding on calculator use as well as significant digits.